This is our TecQuipment student competition enrollment. Our team is Braden Dellinger, Carson McLaughlin, and Colin Clark. We all are mechanical engineers at the University of Michigan-Flint. We'll be analyzing two different heat exchangers. Heat exchangers are used to cool down coolant that has been heated from the engine. So the coolant will travel through tubes and it'll get cooled down by the air and sent back through the engine to cool it down and prevent it from overheating. Our proposed research question is, how does the overall efficiency improve when varying airflow rate of an automotive compact heat exchanger versus 16 tube finned experimental heat exchanger?
So here's the machine used to test these heat exchangers. It is called the TQ-TD1007 water to air heat exchanger. And to set up this machine, we first place the heat exchanger right here in the middle between these two steel frames, and then we clamp it down using these clamps here. Then we'll connect the pipes. The bottom one here is the water supply, and the top one's the water return. After that, we'll plug in our communication, which will relay the information to our computer, which will be collecting our data. After that, the machine is ready to be powered up, and here's where we'll set our temperature, and then we'll turn on our fan and our water. And here's a valve here that will adjust the liters per minute that we want the water rate, and then here's a sliding gate, which will adjust the outlet pressure. So here are the schematics for how the air travels through the machine. And so as you can see, this is the inlet, and then it'll blow over the fan. The fan will push it over through the heat exchanger and out the outlet. And then over here is where we'll be measuring the points on the machine where we'll be measuring the temperatures. So the TAs are all the air temperatures, and the TWs are where we'll be measuring the water temperature. Here's our heat exchangers we used for this competition. The air will be moving across the inside of these frames and be cooled from the tubes that are supplied with water. We add fins in the heat exchangers to help to extend the surface area and help with overall efficiency. And as you can see from this picture, you can see how much more compact the car heat exchanger is. The experimental setup, we have two types of heat exchangers, which we just explained. Then the connection is you can either set it into parallel or series, and we use parallel. The heater tank temperature is 60 degrees Celsius, ambient air pressure is 100, orifice diameter is 100 millimeters, water flow is 0.75 liters per minute, and our airflow rate, which is our variable for this experiment, we go from 200 to 150 to 100 to 50 to 25. And here's a demonstration of our experiment.
So these are the results that we received from the two experiments, with the compact heat exchanger being on the top and the fin being on the bottom. In this graph, we can compare how much water power is being exchanged to the air mass flow rate. We can clearly see that the compact heat exchanger exchanges about 2/3 more than the finned heat exchanger, with both heat exchangers decreasing as the air mass flow rate increases. In this graph, we are now comparing the mean temperature efficiency to air mass flow rate. We can see that the compact heat exchanger with the increased surface area is much more efficient at transferring heat than the finned heat exchanger that has less surface area, with both heat exchangers' temperature efficiency staying fairly constant as the air mass flow rate increases. Now, finally, in this graph, we are comparing the heat transfer coefficients of the two heat exchangers to the air mass flow rate. We can see that the compact heat exchanger is able to exchange much more energy than the finned heat exchanger at all airflow rates, with both heat exchangers getting slightly better at exchanging heat as the air mass flow rate increases. As we can see, the compact heat exchanger outperformed the finned heat exchanger by every metric. This outcome was expected because the compact heat exchanger is a real heat exchanger, and we are comparing it to a heat exchanger that was meant more for a lab setting. But we did not know that the compact heat exchanger would perform better than the finned heat exchanger by such a large margin. Overall, from this competition, we can now see the connections between how an experimental heat exchanger will compare to a real-life application of a heat exchanger. That is the end of our presentation. Thank you for watching our student competition.